Would you like to go
All right, good afternoon, everyone. So today, the main focus we're going to be talking about are present and future value of multiple cash flow streams, which, as we'll get into, is more representative of actual cash flows and time value problems that you'd be dealing with in real life. Before we get into that, a couple quick things. So language scholarship, I think I may have mentioned this already. But if you're interested, this is basically just a scholarship opportunity that's available to all students. If you're interested, there's some information attached here. I definitely recommend checking that out if you have time. It's MTSU versus WKU this Saturday at 6. It's Jones College night, so a lot of faculty members are going to be there attending the game. If you're interested, should be a good time. So a few of you have been asking questions about homework. Right, so just to go over that again real quick, all of your assignments are on D2L under assessments and quizzes. Every single one of your assignments are under here, right? So actually I should probably do student view to make sure I don't accidentally show any grades. Right, so you go to quizzes and all your assignments are going to be under this section here, right? So you have 3 attempts at all homework. I recommend you use all 3 attempts before moving on to the quiz. And I think it's a good time to start working on homework 1. After this week, you can start homework 2, and after you start getting good grades on those, you can move on to the quiz once you're comfortable with that. So you have until the 24th until this is due, right? So again, 2 weeks to the day until your homework and quiz, right? Quiz for 1 and 2 due on the 24th as well. So I do recommend starting on homework 1 if you haven't already. By the end of this week, then also move on to starting homework 2, and then you can move on to the quizzes once you're comfortable with your grades from the homework. Any questions about the assignments? Yes.
So it's just like homework quizzes and then take the quiz.
Yes. Yeah. But it is homework. They're just all listed under the quiz section. Anything else? Yeah.
Would you ever like walk through the homework, not like go over, but just give kind of analysis of what you're doing homework?
Mm-hmm. So the quantitative questions that you're going to be going over are basically what we're working on in class. And I'm using Excel as the calculator that you could use on your homework as well. That's one of the options for you. I do recommend getting comfortable in using Excel as your calculator. But the quantitative questions that you're going to be asking line up with what we're working on in class. There are also going to be some conceptual questions that you'll be going over as well. The vast majority of which we do cover in class. Once in a while, you might find something that you have to do a little searching for to look up. But yeah, we're covering at least 95% of what you're going to be looking at. If you do come across any quantitative questions that we haven't covered in class, let me know. I'm pretty sure I have at least one example for every computative question that you'll be asked. But once in a while I miss them. The question pool that we built is pretty large. If you do have questions, if you're struggling with something, you can post on the discussion board, send me an email, ask in class. But I'll help you. I won't necessarily give you the answer, but I'll at least point you in the direction of how to solve the problem. Any other questions? Yes.
I took the homework 1, and one of the answers for like the quantities was like 99.99 like 7 or something like that, and I rounded it all the way up to like the whole number.
Okay.
Without including the any value of 0.00. Got that wrong?
Okay.
Like, am I supposed to include 0.00?
So usually, right? So when you let's see. Oh no, I already missed it. Right. So typically, it's going to be rounded to the nearest penny. We have to, when we're doing the question, we have to specify what decimal point that you have to answer at, right? So it does note at the top, usually you're going to be rounding to the nearest penny, and the question itself should tell you if there's a difference in how you should be answering the format. So yeah, you do have to pay attention to format. Good point there. You do have to pay attention to format, right? Whenever you're dealing with the software, there's a high degree of specificity that you have to use typically. So yeah, thank you for pointing that out. Anything else? Yes.
You can exit and come back in one, or can you?
I don't remember. With the quizzes, you can't. The homework, you might be able to.
I don't
What's
think
that?
so. When I took it, it didn't have like a save function. It was like all or nothing. Like
Okay.
there's 3 attempts.
Right. Yeah. Especially with the quizzes, I do recommend just don't start until you have time to finish it. But especially after you go through the homework, I don't think the quiz will take all that much time. All right. All right, so most of the examples that we've been looking at have dealt with a single cash flow. Like we have $10,000 already, and we're going to see what that's going to be worth in the future. But typically, when you're dealing with time value problems, it's multiple cash flow streams. Right, over the course of your career, you're not just saving up a single lump sum at the beginning of your career. Typically, you're saving and investing in retirement portfolios, other 529 accounts for kids, any other sort of investment account that you might be interested in. So it's taking place in the form of a cash flow stream, meaning reoccurring time periods. Right. Most of what we've been doing, though, has just started with the single cash flow just because that's a simpler place to start from. But now we're going to start going into a little more detail on how we can have cash flow streams and look at how that's going to affect the value of present and future values over time. And the way that we're going to do this, there's a couple of different methods that we can use. The most generic and useful method, in my opinion, is going to be using a cash flow table. So we're going to be looking at putting together cash flow tables so that we can see explicitly the present and future value of these cash flow streams that we're going to be looking at. And that's going to be useful, especially later on in this course when we get into start using things like net present value, which are the slightly more complicated ways that financial executives at companies evaluate projects. In practice, though, it's just a couple more steps than what we've already done, but it's still using the same idea that we've been using so far. All right, so when we're using multiple cash flows, this results in what's generically termed the discounted cash flow analysis. All right, so, or DCF. All right, so might be using that phrase, DCF, discounted cash flow, is all really you're talking about. All right. The way this is going to work is that we're going to take the present or the future value of each cash flow within each time period that these cash flows occur, and then we sum up all of the present or future values that we're looking at. All right, and this is the basic way that we value any sort of asset or put together any sort of future projection. Right, in this analysis, things can get much more complicated from here, right? Depending on the sort of cash flow that we're looking at. We're going to be dealing with standard cash flow streams in this class. When you get into the more difficult to value things like options, derivatives, stuff like that, then we start adding probabilities to the cash flows that or cash flow streams that we're evaluating. But it's the same basic idea, right? All we do is we take the present or future value of each cash flow, add it all up. All right, and so that's what we're looking at in these formulas here. All right, sigma just means sum. Basically, we're adding up everything that comes to the right-hand side of this sigma sign. So what we're looking at here is a present value. We have a cash flow occurring in the nth year. So it could be 1 year from now, 2 years from now. And we have the discount factor that's tying back this cash flow in the nth year back to today. And we add up all those cash flows over time. Same idea when we're taking the future value, right? Present value, future value. We're multiplying each cash flow now by the compounding factor, adding that all up for our future value. All right, in practice, though, it's going to be relatively more straightforward and easy to implement if you just go through these 4 steps. All right? 4 steps applies to any single cash flow analysis. First step is you set up your time periods. You figure out what is the time frame that your cash flows are going to be occurring. Sometimes this is really easy. Bonds are one of those. When a bond is issued, it tells you the maturity date, so you know the exact time frame that your cash flows are going to be occurring in, right? Fixed income. That fixed aspect is usually the time period that the income is going to be occurring over. So for step number 1, you set up your time periods. Step number 2, you allocate your cash flows. This is going to be an important one because we'll look at a few examples. This can get kind of tricky at times, depending on the cash flows that we're dealing with. All right, so we set up our time periods. 1, 2, we allocate our cash flows into those time periods. Step 3, and this is where time value really comes into play, we discount or compound all of our cash flows. If we're taking a present value, we're going to be discounting. If we're finding a future value, we're going to be compounding. And the last step, we add up all of the discounted or compounded cash flows. Right, every single time, these are the 4 steps that we can apply to figure out what the value of something should be today or what it's expected to be worth in the future. Set up our time periods, allocate our cash flows, discount or compound, add it all up. Same 4 steps, doesn't matter what we're dealing with. If you apply these, then you're at least most of the way there to getting a pretty good idea of what something is worth or will grow to. And like I mentioned, sometimes the timing can be tricky. I'll try to point out some of those distinctions as we're going through examples. Right. Any questions before we start working on some problems? Again, these are the 4 steps that we're going to be following. Basically, the rest of this class, if you're working in the field, you're going to be using this throughout the majority of your career. You set up your time periods, allocate your cash flows, discount or compound, add it all up. All right, so let's move over to Excel. Start working on some problems now. All right, so let's say we're purchasing an asset that's going to pay out $100 over 5 years, has a discount rate of 8%. That's poorly phrased, pays out $5 each year over 5 years. I like the specificity in that. All right, so first step is we're going to be setting up our cash flow table, right? And this is the basic structure for a cash flow table. As we go along throughout the semester, we'll be building on this and adding in more details, but this is the basic layout for it. Right? Step 1, we set up our time periods. Right? Each one of these numbers is reflecting the year the cash flow is taking place. Year 0 is today. It's where we're starting from. It's the point from which we're valuing an asset. So today is the day that we're trying to estimate the value, and whenever we're estimating the value, we're comparing it to the price of access to these future cash flows. All right, so we're starting with today. We have $100 being paid out over 5 years, so we're going to have 5 years that we're going to be allocating this cash flow in. All right, so the time frame is set up for us. Now we're going to allocate our cash flow, $100 each year for 5 years. All right, so I can just copy and paste this once I type it in. Control C, hold down Shift and the arrows to highlight the other cells. Control V to allocate the $100. All right, 2 steps down, right? Pretty easy. We have our time periods. We allocate our cash flows. Next up, we're going to be finding the present value for these cash flows. All right. The way we do that is going to be taking the discount factor. All right, so just, where's my marker? A reminder on what we're doing here. When we are looking at a present value, it's equal to the future value divided by 1 plus R. Right? This is the standard format that we've been dealing with. We can also break this up as 1 plus R again. All right? It's the, shoot, I forgot the mathematical term, where you separate the terms. Anyone remind me?
Oh.
It's slipping my mind. Whatever the term is, right? You know what we're doing here. You multiply anything by 1, it's equal to itself. So we're just taking out the discount factor into its own fraction over here. The distributive property, right? That's it. Yeah, distributive property. All right, so we're taking out our denominator, putting it into its, in this case, its own row. And that's going to make it a little easier, especially when we start having more complicated cash flows later on in this semester, for separating out the information that we're dealing with. Right now, we're dealing with a very simple example. We're just told we are dealing with $100 cash flow. Later in this class, when we actually start calculating cash flows, things are going to get a lot more complicated, and we're going to have far more rows dedicated to putting together that cash flow. Right? So when it comes time for that, it's going to be beneficial to have the cash flows separated from the discount rate that we're applying to those cash flows, because those are different components of the value that we're getting today. Right, so in order to be as informative as possible, we're going to try to allocate bits of information into their own separate spaces so we can physically see what's going on to the value today when we're looking at these future cash flows. So the motivation for having this discount factor separated from the cash flow is basically just for informativeness. So we're going to be focusing on using our discount factors so we can throw that into its own row when we're looking at the Excel sheet here. All right, so that's what we're going to be doing now. We're going to be calculating our discount factor, which is this term here, 1 divided by the discount rate that we've already been calculating. 1 plus our discount rate raised to the number of years. All right, so I have that formula posted over here to the left of the discount factor, just as a reminder. All right, so again, anytime we're making a calculation, start off with the equal sign, 1 divided by 1 plus our discount rate, fixing reference to that discount rate, right? Getting the dollar sign in front of the column and the row. Close up parenthesis, right? Parenthesis allocation is very important. If you don't appropriately close or open parentheses where they're supposed to, you're going to get an incorrect answer, right? Let me just give you an example of that right now. We get 0.93. All right, so that looks right, and that is going to be right in the first year. But where things go wrong is when we start copy and pasting this out, the value actually starts increasing a bit, which is the opposite to what we would expect with the discount factor, because the further into the future we receive a cash flow, the less it's worth today. All right? Always keep that in mind when you're dealing with present value. So I'm going to correctly allocate this parenthesis. Oh. Reference the year that it's in, and I'll copy and paste this over. All right. And as we should expect to see, the discount factor should be declining as we move into the future. Yes?
Why do you have a dollar sign in the?
So this is fixing my reference to the discount rate here. So if I didn't have this dollar sign here, right, Excel's default reference is relative, meaning this B4, it's not necessarily referencing the cell, it's referencing the relation of this cell to this cell. Right? So B4 really means it's going to be 2 columns back and 2 rows up. So if I don't have that fixed reference here, what's going to happen is as I copy and paste this forward, it's now still referencing 2 columns back or 3 rows up. Right? And that's what's happening in every single cell reference moving forward when I copy and paste it. So the reason I'm putting the dollar sign on here is to fix reference in this formula. So when I fix the reference to this 8% here, when I fix the reference to that 8%, now when I copy and paste this forward, all these other cells are still going to reference the 8% as we're intending here. So the entire point is basically just to fix the cell reference to the information that's not changing and allowing the formula to update with information that it is changing, in this case, the year that the cash flow is occurring in. Does that help? Okay. Any other questions on the discount factor?
Could you say what the fixed reference is again, how you do that on
Yep, so you just highlight the cell and you hit F4. Yeah. You can also manually type it in, the dollar sign in front of the column and the row. And Mac was, I think, function 4?
Command T.
Command T? Mm-hmm. Oh, okay. There you have it. I got to remember to get the reference sheet. I'm pretty sure there are some notes for Excel. Let's see. All right. That's not what I'm looking for. All right, I'll try to gather some resources for the Excel shortcuts. I already got it. Thank you. Okay, so course notes, Excel shortcuts, and it'll give you a list of things that we'll be using with the PC and the Mac difference. Thanks for pointing that out. All right, so again, that's under content, course notes, Excel shortcuts. I'll try to remember to mention them as I'm using them in class, but they do save a lot of time when putting together workbooks, especially as our cash flow tables are going to get more complicated. Any other questions? All right. Now the easy part, we get the present value. So to get the present value, right, again, we're just multiplying our discount factor by our cash flow. So we take our discount factor times our cash flow, and that gets us our present value. So we have our present values. So steps 1 through 3 are done. We set up our time periods, allocated our cash flows, took the present or future value, in this case present value. Last step, what's the last step?
Sum it up.
Yeah. Sum it up. All right, so equals sum. We're just adding together all of our present values. So, right, the present value of these cash flows at a discount rate of 8% is $399.27. So, what is that telling us? What is this $399 telling us?
How much assets worth?
Exactly. In other words, how much should we be willing to pay for it? Right? So we should be willing to pay up to $399.27 in order to have access to these cash flows. If, on the other hand, we were being charged $400, would that be worth it? No. The benefit is less than the cost. Right? A lot of things come down to just cost-benefit analysis. Time value is just giving us a framework to get a better idea of what the actual cost and benefit is going to be for a decision. So in this case, once we adjust for time value, we know that access to this cash flow, which nominally is $500, right? When we don't adjust for time value, it's just a $500 cash flow. But in reality, really, its value to us today is $399.25. Any other questions on how we put together that cash flow table? Yes.
Can you show how you got the present value again?
Yes. So to get the present value, we multiply the cash flow times the discount factor. So just what we're doing right here, right? Again, we've automatically calculated this in the previous class because we were just dealing with a single cash flow. But now that we have a cash flow stream, we're disaggregating the cash flow from the discount factor.
And the discount value is 1 over 1 plus r to the n power.
Correct.
So I just can plug that formula into each individual cell in Excel.
Yep, so that's what we did here. So in the first cell, it's exactly what you just said, 1 divided by 1 plus our discount rate of 8% raised to the year. All right, and I copy and paste this over, and the reason this works is I fix the reference to this 8%, and I let the reference drift along with the formula to the year. The year is changing, right? We're going from year 1 to year 2 to year 3 to year 4 to year 5. The discount rate stays the same across the entire time. So the discount rate is fixed, the time periods change. So we're allowing our discount factor to fix reference to our discount rate and change along with the year, right? So if we move forward to the next year, it's referencing year 2, still a fixed discount rate, all the way to year 5, referencing year 5, and again, the fixed discount rate. What else? All right. We're going to be doing a lot of examples with this, right? Just more practice that we do, the more it's going to make sense. Back when I was an undergrad, it took me a long time to really get an understanding of time value. I don't think I had an intuitive understanding until I started getting into grad school, but it just takes time and exposure. I know at the start it seems kind of confusing, but as you practice, mechanically at least, it'll make more sense as you go along. Conceptually, hopefully that'll follow on in the near future. All right, now we're going to look at putting together compounding factor. So compounding factor conceptually it's similar. In practice with the cash flow table, it's going to be one additional step we're going to have to make. Bless you. All right, so let's say that we're investing $2,000 a year and we're earning 6%. How much is this portfolio going to be worth after 5 years? All right, so we have our time frame. Now we have to allocate our cash flow. So we're saving up $2,000. $2,000. Copy and paste this over into the other cells. Now we're going to make our compounding factor. So similar to the present value, our future value is equal to our present value times times 1 plus r to the nth power. So again, we're going to break out the cash flow from the discount factor. Actually, it's already broken out for us easily enough. I don't have to do anything. Never mind. So maybe it won't be helpful with my handwriting, but just to know what we're doing here, right? The present value, what we're saving up is our cash flow. Right? That's the cash flow that's occurring. This compounding factor is the time value adjustment, because whenever we're looking at the value of something, we have the cash flow itself and then the time factor. When does this cash flow occur? So we have these two things that we have to account for, regardless of present value or future value. We're always adjusting for both cash and time. So with present values, we have the cash flow in the future, our future value, that we're discounting with our discount factor. And with our future value, we have our present value, our cash flow that we're saving up, and our compounding factor, how much this is going to be growing in the future. All right, so same 4 steps again. Set up our time periods, that's already done. Allocate our cash flows, we did that. Now we're going to have our compounding factor, which in Excel is going to be one additional step that we're going to have to make here in order to have that appropriately calculated, right? So what we're going to do here, in order to get our self-referencing, copy and paste ready compounding factor, is we're going to take the difference between the last year, fixed reference there, minus the current year, right? So what this is doing in the spread here is it's giving us the amount of time that we compounded for. Right, so again, it's important to remember that the base assumption when we're looking at time value is the cash flow occurs at the end of a year. So if we're saving up $2,000 at the end of year 1, really that's just 1, 2, 3, 4 years that we're going to have to compound that $2,000 at 6%. So what we're doing with taking the difference between the last year and the present year is just calculating how much time we have to compound within this cash flow table. All right, so I'm fixing reference to the rate because the discount rate isn't changing. I'm fixing reference to the last year because that's the end of the time period that we're dealing with. And allowing the current year to float because that's going to be changing a long time as well. All right. Now, opposite to a present value, we should see that the compounding factor is larger earlier on in the cash flow time period. All right, basically because it means we have more time to compound this factor into the future, it's going to be worth more. Right? Remember the mirror opposite graphs that we looked at with present and future values? The further out into the future we receive a cash flow, the less it's going to be worth today. The mirror opposite of that, the longer we have to compound a cash flow, an amount that we're saving, the more it can exponentially grow over time. Right? So the longer we have to compound our savings, the more the compounding factor is going to be increasing. So now we can copy and paste this over, and we should see it's going to be equal to 1 in the last year, which is what we found here. Right? So one thing that we can use to check our work here, the compounding factor should equal 1 in the 5th year. The reason being is we saved up $2,000. How much is $2,000 when you have it on hand? It's itself. It's $2,000. Right? It's not growing. It doesn't have time to compound. So that $2,000 is just going to be worth itself in that last year. All right, we have our compounding factor. We can get our future value. That's going to be our compounding factor times our cash flow. Now we get the total future value of this cash flow stream by summing up all these cash flows. All right, so nominally, we've saved up $10,000, but because of the interest that we're earning on our investment, our total savings ends up being $1,100, right? So $1,200 or $100 and I said that right the first time. $1,200 in compounded interest over this time period. Yes.
How did you do the present value?
So carefully here, right? We're calculating the future value in this particular one, right? We're finding the compounded value over time. So same as the present value, I added up all the future values. And the way we get each one of the individual future values is multiplying the compounding factor by the cash flow. So we multiply the compounding factor by our cash flow. Other questions?
Professor, can you repeat the compounding factor formula?
All right, so the formula itself is 1 plus the compounding rate raised to the year. in practice, in order to have a ready to copy and paste formula in Excel, it's going to be 1 plus the compounding rate, 6% in this example, fixing our reference there, and closing parenthesis. Again, parenthesis management is very important in Excel. Misplacing a parenthesis will result in an incorrect answer most of the time. All right, so closing parenthesis, putting up our exponent now because the number of years is exponential. So that's going to be open parenthesis last year and fixed reference there minus the current year. And then close parenthesis and we've got our compounding factor. All right, and then from there I copy and paste that forward. And that's the compounding factor.
Can you do the value? I can see that one.
The last step.
Yes.
Yep. So the value is just summing up all of the future values in this case. So we summed up these 5 independent future values that we calculated. And that gets us $11,000.
Can you do it for year 2 without having to do the copy and paste?
You mean just redo everything in year 2?
Yes.
Yeah, sure. All right, so I'm just going to go ahead and delete these. Well, I mean, we got to copy and paste the 2,000. I guess we don't have to. We could type it in, right? We got the $2,000. The compounding factor is going to be equal to 1 plus the compounding rate, which we're earning 6%. Close parenthesis, caret, C-A-R-E-T. Open parenthesis, last year, fix that reference, minus the current year. Close parenthesis, and you have the compounding factor. Last step is take the cash flow times the compounding factor, arrive at the future value.
So whenever we're doing the discount factor in the first example, we just select the year. But with this one and the compounding factor, we have to subtract the final year minus the year that we're doing.
Yes. So the difference is what we're trying to accomplish. So with the present value, it's a little bit easier with the discount factor because that's the number of years that we're subtracting back, right? In this time value framework, we're starting at year 0 and discounting everything back. So this first year, it's a full year discounted back. The second year, it's a full 2 years discounted back. With the compounding factor, we have to keep in mind the time frame that we're compounding by, which is what we're adjusting for here when we're dealing with the compounding factor is we saved up $2,000 in the first year, and that's then going to be compounding for 1, 2, 3, 4 years, right? So it's not compounding the entire 5-year period. It only has 4 years to compound interest. So that's what we're showing with our compounding factors, how much time we have to grow this investment by. And so that's why we're calculating the last year minus the current year is we're assuming this cash flow is occurring at the end of year 1. So because it's occurring at the end of this first year, we functionally only have those 4 years for it to grow. What else?
Will the format of the homework be just like this?
No, there's probably going to be some more fluff involved, right? So grandma's going to give you $2,000 a year and you can save it at 8% per year. How much will that be worth in 10 years? Something like that. So there'll be a little more context. I'm starting with as little information as possible and trying to build it up from there. But the structure is going to be the same. When you're dealing with a multiple cash flow stream, $2,000, it doesn't matter what other information you're given. You set up your time periods, you allocate your cash flows, you discount or compound your cash flows, and then add it all up. So it doesn't matter what the situation of the problem entails, you just have to put everything into its correct order and value. It's the same steps every time value problem. Well, present or future value problem. Any other questions? All right, so now we're going to go on and just expand the time period a little bit, right? So We're still earning 6%, we're still saving $2,000, but now we're going to save up an additional 5 years. So we have an additional 5 years of compounding to save by. All right, so I'm going to zoom out a little bit just to make this work a little easier. All right, so we've got 10 years. We allocate our cash flows, so we got the $2,000 being saved up. So copy and paste that over. We're going to calculate our compounding value, which is equal to, open parenthesis, 1 plus the discount rate, fixing that reference to the discount rate, closing the parenthesis, and raising this to the number of years that we're going to be compounding by. Right? And we're going to calculate the years that we're compounding by taking the last year, fixing that reference, minus the current year, and then that finishes our compounding factor. All right, so notice the difference here between the compounding factors. We've got an additional 5 years of growth that we can achieve by, that we can compound this initial investment by. And so we see that the compounding factor is increasing. With these 5 additional years, this first $2,000 is going to be worth about almost 50% more. All right, just because we're adding in another 5 years of growth over this time period. All right, so we have our compounding factor. We're going to copy and paste this forward, and it should be equal to 1 in the 10th year. It is. Great. Now we can get our future value, multiply our cash flow by our compounding factor, $2,000 times 1.7. All right, so again, we see this initial $2,000, same $2,000, it's just allowed to grow an additional 5 years. So we compound that forward. Again, anytime you see those number signs going across, just means it's physically too large for Excel to show. So I'll just increase that column a little bit. And the last step, sum it all up. Again, getting the number signs. If there is no other information in the cell, you can double click it. So there wasn't any other information in M, but if above or below this, there's like some larger bits of information, it can sometimes really expand the column. All right, so now we've saved up an additional 5 years. We've saved up an additional $10,000, but we have significantly more interest that we've accrued over this time. Right now we've got just over $6,000 of interest that we've accrued with an additional 5 years. Question?
How do we know whether we need to do it this way or the way we were doing in Unit 1? What's the difference?
Whether you're dealing with a single cash flow or a cash flow stream. All right, so this is saying that you are investing $2,000 per year. So you save up $2,000 every year. That tells you that you, probably have to put a cash flow table together.
So you're adding money every year.
Exactly. Yes, that is the difference between what we're doing now and what we were doing previously. Now we're focusing on cash flow streams rather than single cash flow occurrences. And the examples we started with, so our first time value, it's just a single savings, in this case of $10,000. Right? So rather than a single savings time period, we have a stream of savings each year.
So these are like recurring payments. Like,
Exactly.
Okay.
Yes. And so, actually, this is kind of getting ahead of myself here, but that's basically what the time value formula is telling us. All right, so a little shortcut here that we're going to be using in some examples in the near future. All right, so if we have $2,000, actually, I can just put it up here. Future value. If we have a 6% rate over 5 years, and we have a payment of $2,000, right, we can also use the Excel function with the future value to get the same answer. Right? And so that's what is occurring with the Excel function is it's asking for a payment, right? A reoccurring cash flow over this time period. Any more questions?
Can I see the value of this for 10 years?
Of what?
The value for 10 years. What was it?
It's $26,000.
Okay, I got it.
Any other questions? So, I jumped ahead of myself here, but there is an easier way to deal with this particular type of cash flow stream. But using a cash flow table is going to be great when we start dealing with really difficult and irregular cash flows, which we're going to be using more later on in this class. And this is basically a subset of the methods that we can use with the cash flow table, but the cash flow table is always going to be more informative than going straight to using this time value function. All right, this time value function, it doesn't show you the interaction of the cash flow occurring every year and how our compounding factor is changing over time, right? This also shows us that the most important time for us to be saving is earlier on in the saving cycle, because the earlier that you can save, the more it's going to compound and grow over time. All right, so now we have a similarly structured question. The only difference here is how much we're growing by has increased. So we've gone from a 6% growth rate to now a 10% growth rate. So now that our interest rate has increased, what do you think is going to happen to how much we've saved at the end of this time? Yeah. The more that we are capable of growing our savings by, the longer we can save, and the more money that we save up, the higher our terminal portfolio value is going to be. All right, so same steps. We have our cash flow. Copy and paste that to the future. We're going to calculate our compounding value, which is going to be 1 plus our growth rate, 10%, fixed, the reference, closed parenthesis, now getting our exponent. Right, the number of years that we're saving by, which is going to be 4 years in this example, minus the current year. So see, if you compare the compounding factor from this example over 5 years compared to the same example we just did over 5 years, but at a rate of 6%, we're adding an additional roughly 20% in value just by increasing the compounding rate that we're growing by over this time. All right, so long as we correctly fixed our references, we can copy and paste this forward now. Looks like that's all good. And we'll get our future value, take our cash flow times our compounding value. Just as we expected, we added more interest on this time relative to the 6%. Can anyone remind me again why this $2,000 is just worth $2,000 in the 5th year?
No time to grow.
Exactly. It's the time period that we receive the cash flow, so there's no time to compound it. So it's just worth itself. All right. Last step. What's our last step? Add up all of the present or future values. So with this additional 4% per year, we're getting about another $1,000 in interest over this same time period. Right, so when we get to this next step, adding another 5 years of compounding, again, we're going to see that there's more interest that's compounding over this time. So we get our $2,000. We'll get our compounding factor, 1 plus 10%, raised to the number of years that we're compounding by. And multiply our compounding factor times our cash flow, not itself. And sum it all up. So we have an additional 5 years, and we've added about $5,500 in interest because now we're earning a 10% interest rate rather than 6%. Any more questions on putting together these cash flow tables? Yes.
You're gonna go with the discount factor.
Yeah. Like just make it up again, or go through it again? I should say make it up. What's that?
I'm just gonna do it again.
Yeah. All right, so the compounding factor is following along with this formula here, 1 plus the compounding rate, close parenthesis, raised to the number of years that we're compounding by.
I'm sorry, not the compounding one, but the discount one.
Oh, yes. So the first example we did today? You're just making the discount factor? Okay. All right, so for the discount factor, it's going to be 1 divided by 1 plus our discount rate raised to the number of years that we're discounting. So in this case, it's going to be 1 divided by, open parenthesis, 1 plus our discount rate, fixing reference there because the discount rate isn't changing over time, closing parenthesis, and raising to the number of years we're discounting by.
So why are you not doing the subtracting by the amount of years by the current year?
So this $100 is occurring at the end of year one. That's a general assumption in time value. Cash flows occur at the end of a time period. So if this $100 is ending at 1 year from now, how much time do we have to discount by? So this is today, and this is 1 year in the future. We will receive our cash flow 1 year in the future. How many years do we have to bring it back?
If you receive the cash flow 1 year in the future.
Yes.
1 year.
Yeah. There's a 1 year time difference between our receipt of cash and today. Same thing in the next years, right? There's 2 years that we have to discount by. When we're looking at the compounding factor, the difference is we've saved up this $2,000 at the end of year one. Right? Again, cash flows occur at the end of a time period. So we have this $2,000 at the end of year one. So how much time is there between the end of year one and the end of year five?
5.
Well, let's count now, right? This is where the timing can get tricky, right? 1, 2, 3, 4 years until the end of year five. Right? So now it's not as clean of a calculation because we have to calculate the difference between today and the end of the time period that we're compounding by. All right? And so that's what we're doing with our compounding factor here is we're getting the number of years we're compounding by, which is just going to be how much time is left after we've saved up the money. So we save up the $2,000 at the end of year one. So we have 1 year to compound it, 2 years, 3 years, 4 years, which is what we're calculating in our exponent here. This is going to be 4 years, right? And we can just show that real quick. 5 minus 1, right? 4 years to grow by, which is what we're putting in our compounding factor. Is that making more sense?
You know, when you say when you're doing a compounding factor, you're going more backwards in the years.
What do you mean?
Like, I feel like you're saying right now you're in compounding factor. You're saying that how long did it take you to save over 5 years? Saying that this is the 5th year, and you're pretty much going back to how much did you save over these 5 years? And this discount factor, I feel like you're saying that how many will you save in the future 5 years?
So I think you're kind of reversing it there, right? So when we're dealing with the compounding factor, we want to know how much something is going to grow by into the future. So we have the $2,000 starting a year from now, and then we're going to save it up for 4 years and invest it over 4 years. With the present value, we're receiving this money in, say, $100 in 5 years and figuring out what that's going to be worth discounted back to today, right? So time zero when we're dealing with time value is today. So 5 years in the future is 5 years forward. When we're dealing with the future value, right, what we have to be paying attention to is the time frame that we're going to be discounting or compounding by. So with the future value, we have $2,000 at the end of year one, which is going to be compounded over 4 years into the future. Right. So present value, we're discounting back to today. Future value, we're compounding forward into the future. Any other questions? All right. All right, now we're going to see some of the value out of putting a cash flow table together now. We're going to have a little bit more unstable of a cash flow. So we start with investing $2,000 a year. We're going to be earning 10%, and we're going to grow the amount that we're saving by 5% each year. So that means we're starting out with $2,000, but now we're going to be growing by 5% per year. Can anyone remind me how we're going to calculate this 5% growth starting in year 2? The what?
Future value equation?
Not quite. Right. This is going back to, I think, the first calculation that we did. Right? We're growing this amount. What's that?
Is it present value?
No. No. So, right, we're starting off with $2,000 and we're growing by 5% per year. How do we reflect that growth each year?
Maybe,
Times it,
yeah.
times it by 5% and then add it to the original value.
Yes. All right, so an easier way to calculate that in Excel is going to be multiplied by 1 plus our 5% and fixing our reference there. All right, so we're growing by 5%, so 5% of $2,000 is $100. So we're adding an additional $100 in savings in that second year. All right, and then we're going to be continuing to grow by 5% over the next 3 years. So the amount that we're saving each year is increasing a little bit over time. And so this is part of the value of using a cash flow table is, as we'll see later on, probably next class, the formula for calculating this future value is going to be much more complicated even than putting together a cash flow table, which is already relatively complicated. All right, how are we going to calculate the compounding value?
A 1 plus rate.
Let's be specific with our parentheses here, all right? Because if we mess up our parentheses, it's gonna give us an incorrect answer. So using parentheses, how are we gonna calculate it?
Open parentheses, 1 plus 10% to the power, close parentheses, to the power of 5 minus 1.
Right. And do we have to have more parentheses on that exponent?
Yeah, open parentheses.
Yes. And remember, we're fixing reference to that terminal year and to our compounding factor. You should arrive at the same answer we did before. Everything's looking good.
You just copy and paste those.
You can, but you're going to also probably have to update the references, right? So if I copy and paste this down, it technically would get me the same answer because the information isn't changed. We still have the 10% rate and we still have the 5 years that we're compounding by. But just be careful when you're copying and pasting like that because the information can change. So I do try to, when we go to a new example, just use the information within the example itself. But yes, in this specific case, we could just have copy and pasted it down. All right, so we have that set up. Now we're going to compound that forward. Again, the compounding factor should still be equal to 1 in that last year. And now we're going to get our future value back to what we've been doing this entire time. We take our compounding factor times our cash flow. Right, so that first year should be the same. What's going to change now is our cash savings is increasing at 5%, so we're going to see a larger savings over this time. And sum it up. Right. So now we've saved an additional $1,200 because we've increased our savings by 5% per year. Now, be careful when we're dealing with discount rates and growth rates. These are two different but related things. Right? The growth rate is increasing how much our cash flow is growing by. Our compounding rate is the interest effect on that savings. All right, so we have two different things that are affecting our terminal value here in the 5th year, how much we save and how much we earn on those savings. And the amount that we can save can change over time. Any questions on the growing cash flow? Yes.
Could you do the compounding factor one more time?
Yep. So our compounding factor is going to be equal to, open parenthesis, 1 plus our compounding rate. I almost referenced the wrong growth rate right there. Fixed reference to our compounding factor, or to our compounding rate. Close parenthesis, and we're getting our exponent. Taking the number of years that we are compounding by, the terminal year minus the current year. And that's going to get us our compounding factor. And then from there, as long as we correctly fixed our references where they need to be fixed, we can copy and paste that forward. Any other questions?
For the compounding factor for the thing with the number that's 1.4641, can you show the formula for that real quick? The top one.
Wait, which one? Here?
Yeah.
So it's the same formula, same process, right? It's going to be 1 plus the compounding rate, close that parenthesis, raised to how many years we're saving by, which is the difference between the last year and the current year.
So I typed in the same thing and I got 1 for each answer.
I can go through and look at your workbook after class and just see, it's probably just like a minor typo with parentheses or something. Show me after class and we can work through that. Any other questions? All right, so now again, we're going to be expanding by another 5 years. So we're going to have an additional 5 years of cash flow growth, increasing our savings. All right, so we'll start out with the $2,000, and then this $2,000 is going to be growing by 5% per year. So by the 10th year, we're saving up $3,100 a year. We'll get our compounding factor. It's going to be equal to 1 plus 10%. And take the spread between the last year and the current year. And we get our compounding factor of 2.35. Again, compounding factor should line up with the previous example we already did. The only thing that's changing is the amount of cash flow that we're growing, that we're saving every year. All right, we have our compounding factor declining from 2.35 to 1 in the last year. And our future value, take the compounding factor times the cash flow. Last year's cash flow is just worth itself. The only difference here is how much we're allowing the decimal to change by. Keep that in mind when you're calculating these answers. The format that you choose for a cell is going to give you how much you're showing. All right, so in the homework, you're usually going to be asked to round to the nearest penny. So that's 2 decimal places. Make sure that your workbook is showing you answers going out to 2 decimal places. All right, sum up all of our compounding values. Now over this year, we've saved up an additional $7,000, just under $7,000 relative to this first time, because we have increased our cash savings over this decade. Two more examples that we're going to work on today. I hear people zoning out the information at this point. Any questions so far, though, on compounding tables, or any more questions? All right, so we're considering a project that's generating $10,000 per year over 8 years. What's the value of the project if it has 0 startup costs and we have a discount rate of 12%? All right, so again, we're dealing with the cash flow stream, right? This is a project, it's generating $10,000 per year. So that tells us that there's going to be reoccurring cash flows. So we're going to allocate that $10,000, $10,000 over 8 years. We'll get our discount factor, 1 divided by 1 plus our discount rate, raised to the year. Fixing reference to that discount rate because that is not changing. As we should expect, the discount factor declines across time. The further into the future we receive money, the less it's worth today. And our present value, $10,000 times our discount factor. Copy that forward. And our present value, again, just summing it all up. So we have a present value of $49,676. Again, what is this telling us? Yeah, how much we should be willing to pay for it. right? There's a difference between value and price, right? They are not necessarily equal. Value is what you're expecting to get. Price is what you're paying. The general economic good decision to make is pay for something if its benefit outweighs the cost, or is at least equal to. Now we have a similar question. Only difference is our cash flow, again, is now growing by 5% per year. All right, so we have our cash flows growing, discount factor staying the same. So we're starting out at $10,000. And that $10,000 is going to be growing by 5% per year. So what's going to happen to the present value now that we have this cash flow growth? Is the present value going to increase or decrease? Here's some muttered answers. Why is that? I'm putting you on the spot. It's okay.
Yeah, honestly, I don't know.
Yeah. So when we're looking at present values, the only thing that's positively related to it is the future cash flow that we're going to receive. Right? So the more that we receive in the future, the more that's going to be worth today. So our cash flow is growing, so because of that cash flow growth, that's going to be worth more today. So the overall value of a growing cash flow project is worth more to us today. Right? So all the inputs are positively related to future value. Only future value is positively related to present value. So the higher our future cash flows, the more it's going to be worth today. The higher our discount rate, the more time until we receive that cash flow, the less it's going to be worth today. All right, so when we add in this 5% growth rate, it's going to increase the value of this cash flow stream because by the last year, we're going to receive $14,000. All right, so let's get together our discount factor. It's going to be 1 divided by open parenthesis 1 plus our discount rate of 10%, fixing that reference, closing parenthesis, and raising that denominator to the year that you're in. So again, we should end up with the same discount factor. The reason the present value is going to increase over time relative to our previous example is because we have this cash flow growth occurring over this time. So now the total value is going to increase to just over $57,500. All right, so in other words, we'd be willing to pay more for this growing cash flow than we would the fixed cash flow. And in general, that's the case. And what people have to do in something like retirement, when they're trying to index their retirement earnings, they'll typically index it to something like the inflation rate. So they're going to expect a growing cash flow over that time. Paying for something like that is going to be a little bit more expensive because you're paying for more future cash. Any questions on cash flow tables? I know this was a lot. We're going to keep on doing some more examples over time. At this point, again, I'd already recommended that you get working on your first homework. Strongly recommend you get working on that now if you haven't already. I already did one attempt on my first homework, so get through and work on your homework 1 attempts. By the end of the week, you should be good to start your homework 2. If you have any other questions, I'll be around for a little bit. If you're having problems in your Excel sheet, coming up and we can work through those as well.
If we were to do like a one-time investment, you could like sit for a while for like a retirement
I don't remember a brokerage that's associated with them, but if you search online brokerages, you'll find some good options. Right, Merrill, Schwab, Fidelity. There's a lot of options. Then you basically just transfer money into that account and figure out what investment to. So like a S&P 500 ETF, low cost, something like that's great over time. Let me just upload the classic Excel file so we have all that.
So, My class making tissue.
Weird.
Pretty much like. Yeah, people were talking about. It's like to get in class, the last, like end of the class.
Oh,
I had something last.
formatting. It's in currency format.
Oh.
So it's rounding up to the nearest dollar. So if you put it into a decimal format or comma, that should fix it.
Even if y'all don't talk.
Fix it.
Oh, y'all be able to find. It's so like, boy, they start telling them what they don't been through.
Highlight the value. So exit the formula.
I'm wondering.
So just highlight
I heard him, but I'll like more probably.
highlight the cells that you want to change.
This is he cool. I'm in here like I'm really.
Yeah, I bet we have it in a different format too.
Yeah, I think so too. This one.
It was worth it.
There you go.
Okay, I think we're having a format issue.
Okay.
So, what is it supposed to be in?
It depends what you're looking at. She was looking at the compounding factor. The compounding factor should be in decimal.
Okay, he was looking at this one.
Yeah, I think I'm looking at it.
Yep, so hit the comma there. Yep. There you go. Yeah. So it changed your compounding factor.
Okay, that makes more sense. And that's,
Yeah, so the one I had.
oh yeah, that's the same answer.
Yeah.
Okay, amazing. And do you think it should be important about the decimals or just keep it that way?
So I forgot to mention this in class. So when you're dealing with dollars, keep it in dollar format.
Keep it in dollar
Our
format.
compounding and discount factors, keep that in decimal.
Decimal?
Can you remind me to mention that in
Okay.
class next week?
Yes.
Thank
Well,
you.
maybe.
Yeah.
We'll see.
Maybe one of the three of us will remember.
Yes, we'll see about that.
Okay.
So I was having issues with this one. When I was doing, Ethan was holding me and we did it right here. It's a totally different thing. So I don't know if I get off my currency.
Cash flows, yes. Cash flows, cash flow, D format.
Okay, so I don't know if I was doing this one because
So how do you figure out what we're growing?
we were multiplying by
Careful here. We have a compounding rate and a growth rate. Right? The compounding rate is our interest on the investment.
Okay, so
Our
the
growth
growing
rate,
rate.
that's how much, yeah, that's how much we're
So
paying.
it's that.
Close. So if you hit enter now, that's telling you how much you're growing by.
Yes.
Right, so there's one additional step.
Still up here. Next question.
1 plus or 2 plus?
Nope.
For this one?
1 plus.
1 plus,
Yes.
okay.
So that 1 is keeping the initial $2,000, right? $2,000 that you're saving
Oh,
up,
I'm never gonna make
plus
it work. So
interest that you're,
Would I just put it
or
in
that you're
parentheses
growing by.
and that?
Yeah.
let's least like let's shoot for 637.
Do I need to have the
Yes,
dollar sign?
yeah. So
yes, actually you do.
Okay, there we go.
Hold on, you need a dollar sign on the column and the row. Mm. You went on the wrong spot. Oh, that's where it is. So you're not there. So you have the dollar sign in front of the
Yeah, you
D.
just had it on.
Yeah, it's just going on the growth rate. So it's going on the growth rate column and the growth rate row. So in front of the 48.
I was figuring out this one because I had it on.
Yeah, I have to go
There you
in.
go. Yeah. Now when you copy it, it should continue growing.
Currency.
Okay.
Yeah, I had it on currency
This
too.
part, I kept getting something
It's like I have it on there from the
Oh,
other class.
there it
so
is. It's on
I'm trying to go.
percentage.
I had to put a little no sign out for you.
Currency.
For the compounding factor?
Yeah.
Yeah.
Try to go back and
Definitely.
forth using Excel in 2 classes. Is
Yeah.
nice.
Yeah.
It's okay. It's making me
And
forced
it
to learn.
didn't.
Right.
What gives you the answer?
So it's,
Did you get that one?
it's this, right?
Which ones?
These two?
Not yet. Alright, so you're kind of skipping ahead there.
We're
We're looking for the factor itself, right? So we're calculating everything that's inside those
Oh,
parentheses.
okay.
First formula, I guess he teaches.
That's what I thought it was, but I was like.
Get to multiply. Excel is a pain
Is
like
it
that.
multiple? Oh, okay.
Before the
I think that
parentheses, there you go.
when he keeps going faster, that's when I get a little lost.
So it's
He's like, hold on. I'm trying to take a picture. I'm trying to learn. I promise y'all I'm trying to learn.
Am I doing the minus right there
Mhm.
too?
We gotta put the exponent in parentheses, there you go. Fixing your reference there to the 5.
I think because
To the fifth year, no, the X bar.
Oh, with the,
Yeah, the dollar sign, and then the 49.
oh, okay, that makes more sense. Okay.
And so you skipped ahead a little bit here. You calculated the future value.
Okay.
All we're looking for is the compounding factor in this row. So take out your reference to the cash flow, right? You don't actually need that bit. And the multiplication,
Okay, so it's just gonna be at that.
there you go.
switch it.
Okay,
There
okay,
you
okay, cool. So that's what I was like.
This one is
Now you have the, looks like one of your references isn't fixed. Your growth rate, your compounding rate. Let's go back to that first cell. Also get a fixed reference on B47.
Okay, that's where I always get.
And you need it on the,
Oh,
and
amazing.
if you go to the Excel shortcut list,
It'll do it for me.
it'll tell you what the function is to
Okay.
automatically reference the entire cell that you're.
Okay, wonderful. Okay, so then.
Oh, careful, careful.
Maybe you change the format.
You're going on to another time period, yeah. So in general, you want to stay within each year when you're calculating the present and future values.
You know?
There is. So you're
Okay, that makes more sense.
Do I have that on?
kind of mixing up steps again, right? So you have your cash flow,
Uh-huh.
you calculated that, you have your compounding factor. So in this last step, you're just multiplying them together.
Okay, oh, yeah, those two.
Yeah.
Yes. So I was doing that with all the
Yeah.
Excel cheat sheets.
I used to use Windows, like regular.
There you go.
Yeah, HP, that kind of thing in Excel.
Okay,
Is
yeah. That's, I was stuck
easier.
on that part.
Well, I got used to it, so now I'm learning how to do it on Mac.
Thank you.
I got the worst part. It's just like no matter what I did, like I kept taking it back to.
Really?
Okay, cool. Thank you so much.
She gave me the worst. And I switched it back, and I had got,
There you go.
you know, what's it called
I have
six.
a quick
Yeah.
question about the homework.
Okay.
So this was my answer. I don't know if that's the right one, but do I?
So, yeah, so enter
What is
four
your
decimal places, so
What is your
1,
name?
4.
Yeah, I'm Abby.
Let's figure it out.
I still got it wrong. Basically.
I don't wear my friends.
You should wear
I'm
them.
gonna say like
I know, I should, but my dad, hold on. He said offensive play the one time.
I don't think so.
Never worn pants. But I looked
They always be saying the wrong thing. It's not like that's the last thing I want to
We're
read.
gonna be working on
Figure it out.
class 2,
It's
the
fine.
question itself.
Yeah, I got mine. Mine was like in the wrong currency, and then
Yeah.
I was like getting everything mixed up.
Yeah, same. I was getting frustrated.
Okay,
I was
this
like,
is
what am I
an
doing wrong?
Alright, so
That's how I got behind and didn't get these.
this is a rate problem, right? So we have $16,000, we need $20,000.
Yes.
Oh, no,
like,
I'll
So,
backlash.
Yeah,
how much time do we have
we'll see.
to make that
You
goal?
know,
Yeah,
you're
no. Yes.
You're talking for our
No other
right?
options.
Yes,
Okay.
yeah, the rate. But how much time do we have to meet this goal?
We'll see you guys on Thursday. Well, I mean tomorrow.
I'll see you tomorrow.
Yeah.
Right, okay.
So that's the 3 bits of input that we need. The number of years. The number of years, the present value, $16,000, and the future value, the goal, $20,000. So you plug that information into the rate, make sure you're not using the payment instead of the present value, right? This is a lump sum question,
Yeah.
not a reoccurring cash
Okay.
flow.
Okay, got it. All right. Thank you.
I hope that's right. We'll see.
Professor, if I want to go back into, I guess, the online recording thing, that will appear there?
The Excel sheet,
Yeah.
I just uploaded it, so
Oh, you're going to upload it?
I already did.
Oh, okay.
So go to content, so practice,
Uh-huh.
and this workbook here, I just updated it at the end of class.
Also
So
appears
this has
everything
what
you
we
have done there? Oh, amazing.
And if it's not, then tell me.
Okay, thank you so much. Yeah.
I'm sorry. I'm sorry. But I have another class that uses Excel
Yeah, which one?
I take statistical methods.
Oh, no,
Yeah.
yeah, for sure.
I'm learning.
I took it online and I didn't learn much, honestly.
Yeah, I learned
Thank you
math
for your help.
math classes.
Yeah, no problem.
Yeah, it's better to be in person.
Yes, I almost took this one online. I'm glad.
Oh, no, I wouldn't take
Yeah,
it.
it's kind of surprising. I came across some research recently that really dug into online versus in-person classes, and there's a pretty
Yeah,
stark difference.
person, like this kind of class, I would rather in person.
Yeah.
Thank you, Professor.
You too.
Thank you.
No problem.
Helping me learn my computer.
Well, that's helpful to learn.
Yes. Like I was telling him, I've had like a Mac for maybe 2-3 years,
Mhm.
and I'm just now learning how to use these functions.
Oh, okay.
But
There's still things that I'm learning as well with those. It was last year I built a computer for the first time. And yeah, that's taught me a lot about how to use them.
yes, and I got a cheat sheet like off of Temu to put on the side of it for like different functions. But I think I'm gonna find another one for Excel for Mac,
Okay.
just to have in my Access.
Yeah, and yeah, thank you for pointing that out in class. I thought I had one up there, but I couldn't remember where I listed it.
I found it. That was the first thing I saw. I saw Excel and I saw you put up there. I
Okay.
said download.
Good.
Thank you.
Have a good day.